Hello everyone, myself Guruswami Gaud, Assistant Professor, Civil Engineering Department from St. Martin's Engineering College. Now discuss on topic is different types of beams and acting the shear force and bending moment diagram on different types of loads. Now first of all, beam. Beam is a horizontal structure. Its main purpose is to transfer the load from superstructure to substructures. So it is a horizontal structure beam. It rests on columns or supports. Then when apply the load on the beam, it will be transferred through columns to foundation. Finally, the main purpose of beam is to transfer the load from superstructure to substructure. Okay. Now, the beams are classified into different types based on the support conditions. Now we can see different types of beams. There is a cantilever beam and simply supported beam, and fixed beam, continuous beam, overhanging beam. Then first one, cantilever beam. It is a cantilever beam as shown figure. It is one side, beam of the one side is fixed support, other end is free end. Then it is called the cantilever beam. And second one is simply supported beam. The beam is horizontal structure. It rests on two supports. One is hinge support, another one is roller support. It calls simply supported beam. There is no horizontal movement. It allows only horizontal movement. Next one, overhanging beam. The beam is freely supported on supports and having both ends are more than the support length. And next one, fixed beam. The beam ends are supported with fixed. They have vertical reaction, horizontal reaction, and movement reaction at support. And next one, continuous beam. The beam is rest on more than two supports. If less than the two support, it is called one side fixed is cantilever beam. Two supports are simply supported. More than the two supports, it is called continuous beam. If the beam is extended from the support, it calls overhanging beam. And next one, types of loads. The loads acting on the beams are different types. One is concentrated load and UDL and UVL and moment load. The point load or concentrated load is relative to a smaller area. It place on particular area only. Then the load is transferred through the overall the beam. And next one, uniformly distributed load like a vehicle, petrol tank vehicle. Here the load is distributed uniformly throughout the length of the beam. Uniformly. The units are for UDL is Newton per meter or kilonewton per meter. And next one, uniformly varying load. The load of the intensity is varying from one position to other position on the beam. It's called uniform varying load. Here also the units are Newton per meter, like these figures. So triangle and conical shape. And next one, these are some different types of load figures shown here. Here concentrated load W1 and W2. Here UDL, the units are W kilonewton per meter. And next one, it is a roof structure. It likes a UVL. The point of contraflexion is acting at 1/3 from the length of the beam. And next one, last one is concentrated load. Next one, the support types of supports. First one is simply support. If the beam is rest on the supports, is called simply support. And next one, roller support. It is the support having the roller movement. So it having only horizontal movement only. The reaction acts at vertical shape only. And next one, fixed support. It is once the support is fixed on the beam at either starting or ending of the beam. So here having the horizontal reaction and vertical reaction and movement of the section support. And next one is types of support, hinge support. It is like a dooring support. It's having only inclined reaction or vertical reaction only, like this. It is a simple support, horizontal surface and roller supports. It is hinge supports, fixed support. And next one, shear force at a section. So shear force is the algebraic sum of all the vertical forces on the left or right of the section is shear force. Shear bending moment is the algebraic sum of all the forces, all the movement about the forces is known as the bending moment. The shear force units are kilonewton, yet the bending moment units are Newton meter or kilonewton meter. And next one, moment. It is the product of the force and perpendicular of the line of the action. So it is F equal means movement M equal to force into distance of the point location to end of the point. So next, bending moment. The moment which causes to the bending effect of the beam is known as the bending moment. It is generally denoted by M, capital M, and shear force is generally denoted by capital F. And sign convention of the shear force. So it is left. It is we can assume the beam from ear to ear. It is left support. At the left support, the upward reaction is positive and downward reaction is negative. At the right support, downward reaction is negative, upward reaction is positive. And next one, bending sign convention of bending moment. So the bending moment signing convention are two types: sagging moment and hogging moment. We can consider the sagging moment is positive bending moment and hogging moment is negative bending moment. In sagging bending moment, convexity is lower end, and in hogging bending moment, convexity is upper side of the curve. And next one, the shear force bending moment diagrams means it shows the represent of the shear force and bending moment throughout the beam with the line of the actions variations. And next one, point of contraflexion or inflection of the point. It means the bending moment sign changes from positive to negative or vice versa, negative to positive. At the point is called point of contraflexion and inflection. And next one, relationship between shear force, bending moment, and load. So now we consider the simply supported beam acting the uniformly distributed load with W kilonewton per meter. We can consider the small particle on the beam with distance of dx. Then cutting the two sides of the particle, xx and xx dash portions. Now consider at xx portion we have one vertical reaction downward side and movement is capital M, and opposite of right action, right side of the portion, we have upward reaction V plus dV and movement is M plus dm. Now applying the equilibrium equation conditions, then finally we get equation is V dx equal dm, then V equal dm by dx. It is the shear force is equal to the rate of movement. And next one, now applying the equilibrium equation Fy, then finally we get minus V plus dm equal to 0, then W equal to dV by dx. W means the load is equal to rate of load of shear force. The variation of shear force and bending moment lines diagrams. So shear force diagram, bending moment diagram based on the type of load. First one, if acting the point load, then horizontal line in shear force diagram. In acting the UDL, incline line. In UVL, 2 degree curve parabola. For bending moment is when acting the point load on the beam, it is incline line, and UDL 2 degree parabola. If acting the UVL on the simply supported beam, then bending moment curve is 3 degree curve parabola. Now We can derive, now we derive the shear force diagram and bending moment diagram for simply supported beam. For simply supported beam, when acting a center point load, center point load W. Now consider the beam length of L meter. Consider the beam AB, simply supported beam, length of L meters, then supports at A and B and acting a center point load W at the beam. Now for finding the shear force and bending moment, we can calculate 3 steps. First one, applying the equilibrium equation. So sigma V equal to 0, it means all the vertical forces on the section is equal to 0. Now we consider the supports A and B are hinged supports, then acting the reactions, upward reactions RA and RB. Now on the beam we have one downward load and upward reactions at the support. Then applying the sigma V equal to 0, then upward reaction, sum of upward reactions equal sum of downward reaction W. Therefore, RB equal to, or RA equal, RA plus RB equal to W. Now, taking the moment at point A, sigma MA equal to 0. Now, from B, acting the vertical reaction at the B, RB into perpendicular distance from B to A is length L meter minus acting the downward reaction, it consider the negative minus W. From the point of the load to A distance is L by 2, then L by 2 equal to 0. Therefore, RB equal to W by 2. Then the RB value substitute here in sigma V equal to 0, it becomes RA plus W by 2 equal to W, then RA equal to W by 2. Okay. So here we can find the reactions of the beam. Now finding the shear force. So RA equal to W by 2, RB equal to W by 2. Shear force at point A left side is 0 because there is no bending moment, it is only simply supported, it is not overhanging. Shear force at A from right side, we are acting the reaction force at point A, then it is RA. So reaction is upward from the left portion, it is plus W by 2. Next one, shear force from A to C means loading point. There is no load in between A to C. Then shear force is constant in between AC. Therefore, shear force at point C is W by 2. But acting the load W at point C downward direction, then at point C right side is W by 2 minus W equal to minus W by 2. Finally, at point B, shear force is from C to B is no load constant, then shear force also at point B is minus W by 2 left side. shear force at point B right side is, so acting the minus W by 2 plus W by 2 reaction, that equal to 0. Now bending moment at point A and B is 0 because supports A and B is hinged supports, so it is a simply supported beam. There is no bending moment, so it is taking 0. So MA equal to MB equal to 0. Now the load is acting at the point of center of the beam, then bending moment at the center or at point C is MC equal to, taking the, so A, B center point, taking the left or right portion of the section. So now I consider the left to right portion of the beam from the section. Therefore MC equal to, so at B acting the force RB into, at the C distance from B to C distance is L by 2. That equal to minus W by 2 into L by 2. WL by 4. So finally, the shear force diagram and bending moment diagram for simply supported beam when acting the point load at center L by 2, L by 2. So we can draw the plotted axis. So neutral axis is for shear force and bending moment is 0. At point A, we have shear force is W by 2 plus W by 2. Next, from A to C is there is no load, so constant plus W by 2. At point C, we have W loading, so total W minus W by 2 here. So from C to B is also constant loading, then minus W by 2. It is shear force diagram, SFD. And the next one, BMD. So at point A and B is 0. At point C, we get WL by 4 and draw the inclined lines for point load. Okay. Now going on video. Now goes the video. So one small exercise problem on simply supported beam acting the concentrated loads. Okay. Now, so it is the diagrams. Draw the SFD bending moment diagram of the beam shown in figure below. So it is simply supported beam acting to overall length is 5 meters, and we have 2 point loads. So 5 kilonewton, 7 kilonewton. 5 kilonewton is the acting place 1.5 meter from the support A, and 7 kilonewtons is placed on 3.5 meter from the support A. Total A to B length is 5 meters. We apply the equilibrium equation conditions. So step 1, calculate the reaction forces on the RA and RB. So the support A and B is hinged supports, then acting the only vertical reactions only. So we can apply the sigma V equal to 0 equilibrium equation condition. RA plus RB upward forces equal downward forces 5 plus 7. Then RA plus RB equal 5 plus 7, that equal to RA plus RB equal to 12. Now applying the movement, so sigma MA equal to 0, then movement at point A or at point B equal to 0, then we can take sigma MA equal to 0. So the movement, all the forces from above the A is 0. Then RB into B to A distance is 5 meter, RB into 5 minus 7 into D to A distance is 3.5, and next one point load is 5. 5 into C to A distance is 1.5. Then finally we get RB into 5 equal to 7 into 3.5 plus 5 into 1.5. Then RB equal 3.5. Then RB equal 5 into 1.5, 7 into 3.5, that equal to RB into 5. Then RB equal RB equal to 6.4 kilonewton. Then we know the RB value from the applying the moment at point A equal to 0. Then we can substitute the RB value at the reaction of RA plus RB equal to 12 equation. Then we get RA plus RB equal to 12. Then RA plus RB equal to 12, substitute the 6.4, then we get RA equal to 5.6. Now, step 2 is calculation of shear force. Now, consider the shear force at A is left is no beam, then it is 0. And next one, shear force at point A from A, point from A to right side. Shear force at point A to its right. Then here we have the support reaction RA upward. So the shear force is RA, SF at A equal to RA. So the reaction is direction is upward direction. Then it will be positive plus 5.6 kilonewton. Now the shear force at point C to its left is equal to in between A to C is there is no loading, then constant loading. Therefore, shear force is 5.6 at point C left. Okay. Next one, shear force at point C to its right side is acting at point C, acting the load 5 kilonewton at downward side. Then it will be neglected from the 5.6. It will get minus 0.6 kilonewton here. Minus 0.6 kilonewton. There plus 0.6. Now at point C to D is there is no loading. Okay. Therefore, the shear force is constant from C to D. At point C, we get right side of the shear force is 0.6. Then is constant from C to D is 0.6 kilonewton. Now, at point D, right side is acting the 7 kilonewton. At point D, acting 7 kilonewton downward direction. Then force, shear force at point D is 0.6 minus 7, that equal to minus 6.4 kilonewton at point D. From D to B is there is no loading, it is constant loading in between D to B. Therefore, the shear force at point D right side and the shear force at point B left side is equal. So it is constant minus 6.4. So at point B right side is there is no beam, it is 0. It will be becomes to shear force is 0. So here drawing the shear force diagram. At point A is 0. Finally, we calculate at point A is 5.6 upward direction. And A to C is there is no at A to C is there is no loading. It is constant. It is constant. Then the shear force is constant line 5.6 neutral line. At point C having the at point C having the 5 kilonewton downward direction, then it subtract from the 5.6, 5.6 minus 5 equal to 0.6 at point C. From C to D is there is no loading, so constant shear force. At point D, all acting 7 kilonewtons downward direction. Then 6.6 minus 7 equal to minus 6.4 kilonewton. From D to B is there is no loading, it is constant shear force minus 6.4 kilonewton. Okay. At point B, we have vertical reaction 6.4. So we have minus 6.4 plus 6.4 equal to 0 at point B. Now, now to find the bending moment, 5, 7 kilonewton, 1.5 meter, 3.5 meter, 5 meter. RA is 5.6, RB is 6.4. We know the simply supported beam at point A and B is injured support, then bending moment at point A and B is 0. Then sigma or MA equal to MB equal to 0. Now the moment is under the point loads, then the point loads is 5 meter and 7 kilonewton subjected at point 1.5 meter from the AC and 3 point from the A. Now moment at 5 kilonewton, moment at the 5 kilonewton, M5 equal RA into distance, RA into distance from A to C is 1.5. That equal 5.6 into 1.5, 8.9 kNm, kilonewton meter or units. At M 7 kilonewtons, RA into 3.5. So it is from A to D distance is 3.5 meters. Okay, RA into 3.5 minus the downward direction at point C is 5 kilonewton minus 5. From C to D distance is 2 meter. That equal 5.6 into 3.5 minus 5 into 2, that equal 7.22 kilonewton meter. Then finally draw the shear force and bending moment diagram. So shear force diagram is at point A is 5.6. So from A to C is constant, 1.5 meter. At C 5, from C to D 0.6, at D 6, 6.4, 0.6 minus 4, it is 0. B, D, C and A. So it is shear force diagram. So upward is positive, downward is negative. Now bending moment diagram. Drawing the neutral line from A to B. So at A is 0 moment, at B is 0, at point C is 5.6 into 1.5, 8.9 kilonewton meter, and next one at point D is 9.88 kN. Okay. Now we can discuss about different types of load when acting the simply supported beam. If acting the UDL, otherwise taking the cantilever beam, acting the point load at enter W with length of L meter, then shear force diagram is W into L, W, total shear force diagram is W. When acting the shear W both sides, for bending moment is at point B is 0, at point B is 0, at A is fixed support, then moment equal to load into perpendicular distance, W into length from B to A is L meter, then W into L. It is shear force diagram, it is bending moment. Now consider the simply supported beam. Applying the uniform distributed load entire the beam, W Newton per meter, length of L meter, then shear force At A is RA, at B is RB, now bending moment is parabola. So at A and B is 0. At the load is acting uniform distributed load. The maximum load occurring at the center point load. Then the bending moment at the center is WL square by 8. Okay. Thank you for watching.